Yes, guys. So let me continue from question number 8 here you were doing. Okay, now let me take question number 8. What did it say? It says in the curve x the raised power 2 by 3 plus y raised power 2 by 3. Here curve is given. Let me write here question number 8. Curve is x raised power 2 by 3 plus y raised power 2 by 3. Okay, is equal to a raised power 2 by 3. Okay, this is the curve here. Now then show that, to show here, there are two results here. First result is we have to show that S is equal to 3 by 4 A into cos of 2 psi angle. Okay, where S being measured from, I will just take it that from where it is measured, where S is measured from the vertex. So S is measured from vertex. S is from vertex. Measured from vertex. I'll just talk about what is the vertex here. So vertex is at the middle point of this point. I'll just talk about being measured from the vertex. And second point is S equal to, this is 3 by 2. It is 3 by 2 A into sine square psi. Sine square psi. Second point, this we have to prove 3 by 2 A sine square psi, where now S is measured from the cusp on the x-axis. Now here S is measured. S is measured from cusp, not from vertex, but cusp from the on the x-axis. Cusp on x-axis. Cusp on x-axis. Alright, cusp here on x-axis. We will talk about it, how that point t is given there 0. Okay. Now let me take what kind of this curve is. Now we have discussed about this. Let me find a solution. Now I have discussed about this, that if I write it as x upon a whole power 2 by 3, no problem, plus y upon a whole power 2 by 3 is equal to 1. Okay, so from this, if I equate this to 0, y equal to 0, suppose then x equal to plus minus a at y equal to 0, and at x equal to 0, y equal to plus minus a. What kind of curve is this? The curve is we have traced. This kind of curve will be obtained. This kind of curve will be obtained. Okay, here it is a0. This is x-axis. X dash axis. This is minus a and 0. This is 0 and a minus a. Sorry. This is 0 and plus positive. This is y-axis. Y dash axis. Origin O. This is a. This is also a length. This is a. This is a here. Okay, so this is the cusp. This kind of curve. Curve is traced like this. Now let me solve it by assuming something by parametric form. So parametric equation, if I substitute something, so substituting or putting, let me take parametric equation here, x equal to a cos qt and y equal to a sin qt are the parametric form or parametric equations of this curve. Okay, these are the parametric equations of this curve. So let me find what is dx upon dt and dy upon dt. Here t is a parameter. So therefore dx upon dt is equal to, this is minus 3. It's minus 3a into cos square t. Cos is differentiated as minus sin t. That's why I'm taking minus sign here. So this is into sin t. Minus 3a cos square t. First it will be 3 into a into cos square t. Then cos is again differentiated by function of a function method. So cos is differentiated as minus sin t. So this is negative sign. And d by dt from The second equation, a sin qt, is 3a sin square t into cos t. Therefore, now if I have to find out dy upon dx, okay, dy upon dx, which is sin psi, okay, but let me first find out what is the length here. So s or ds upon dt, let me write ds upon dt, therefore is equal to, it will be dx dt whole square d by dt whole square. We have to find out s here. So this is the s, but in terms of psi angle, because it is intrinsic equation, we have to find out the intrinsic equation here, in which s equal to 3 upon 4 is cos 2 psi. But before that, let me just solve it. So here dx dt, we know that this is dx upon dt whole square d by dt whole square. If I substitute these values, it will give us square of them. Sorry. So it is 9a square, first is dx upon dt, it is cos 4t sin square t. Again this is 9a square sin 4t cos square t. If I take common, what I would take common here? Okay, cos square t sin square t. This is 9a square. If I take sin square t into cos square t common, it will be cos square t from first plus sin square t from second. So this is 1. It is nothing but 9a square into sin square t into cos square t into 1. So this is trigonometric identity, since sin square theta plus cos square theta is equal to 1. So this is 1 here, 1 into this. Therefore, ds upon dt, if I have to find out, it is nothing but 3a into sin t into cos t. Now if I multiply this by 2 and divide by 2, so it will give us 3 by 2 into, okay, a into 2 sin t into cos t. It is, or it can be written as 3 by 2a into sin 2t. Simple. This is value of ds dt. But before that, let me find out what is tan psi, the relationship between t and psi angle. Let's find out that. You know that since tan psi equal to dy dx in case of Cartesian equations, but this is d by dt oblique dx dt. Now if I substitute those values, d by dt and dx dt was this, d by dt is 3a sin square t into cos t divided by minus 3a into cos square t into sin t. Okay, this value was of dx dt. This 3a cancel out, but with negative sign here. Cos square t sin square t, 1 sin t cancel out, 1 cos t cancel out. This is sin t upon cos t, it's minus tan t. Try to understand. Now it can be written as tan of minus t, because minus tan t is, because tan is odd function, so negative sign will be minus tan t. This is, so tan minus t can also be written. So here psi equal to minus t. This implies that. So psi can be written as minus t here. Okay, so what are the limits? Let me take, because s length we have to find out from vertex. So vertex can be taken at the middle point of this. Now at the middle point of this, psi equal to minus pi by 4. Note down this. At this point, if I draw the tangent line, then at that point psi angle will be pi by 4, minus pi by 4. Therefore t is equal to here positive pi by 4, because psi is minus t. So psi is t is pi by 4. So from this vertex, it says from vertex to point T. Okay, so vertex is pi by 4, or from pi by 4 to T I have to find out. So therefore, let me find out therefore S equal to, so length of the arc, therefore length of the arc from the vertex, where psi equal to minus pi by 4, imply that T equal to pi by 4 to T equal to T. Let me take. So therefore S is equal to limits pi by 4 to T. Okay, here it is ds dt into dt, or ds dt is this 3 by 2a sine 2t. Let me write it here. Okay, that value is, can be written here, pi by 4 to t. ds dt is 3 by 2 a sine 2t into dt. Now first let me integrate this. Now integration of this will give us 3 by 2a. Let me take outside the sign of integration. Sine 2t is integrated as minus cos 2t upon 2. Okay, limits pi by 4 to t. It will give us 3 by 2a, or this 2 will also come out. This is 3 by 4a. Okay, and at t it is minus cos 2t only. Minus plus here in between. Now cos 2t into pi by 4. T is pi by 4, so it is cos pi by 2. Cos pi by 2 is 0. It is nothing but minus 3 by 4a into cos 2t. Okay, this can be written as, because t is minus psi, t is equal to, here t was minus psi here, or minus psi equal to this, t equal to minus psi, or yeah, t equal to minus psi. Because of that, if I substitute here psi angle, that will give us positive value. So here psi is positive value, so t I can substitute, can be taken as 3 by 4. So S length is, S the length of the curve from the vertex to the point T, to the point, any unknown point T. So here psi equal to pi by 4 minus pi by 4, and t equal to pi by 4 to T. So the length is here 3 by 4a into cos omega, 2 omega, twice of omega sine, not omega but psi. This is psi angle, twice psi angle. This is the value. First question is S equal to 3 by 4 a cos 2 psi. This is the length S being measured from the vertex. When S is measured from the vertex, and psi is minus pi by 4, or t is equal to, because t was minus psi, therefore t is positive pi by 4. From that point we took that value. Okay, so this is the answer. The first answer is this. Now second point. Now let me take the second point here. Only the limits are changed. In the second point it says, okay, in the second point it says that, okay, from second point is from S equal to 3 by 2a sine square psi, where S being measured from the cusp on the x-axis. From the cusp on the x-axis, if I suppose this is A point here, this is B point, and that was the middle point of this was the vertex here, and from A to B, and this is the point cusp here. At the cusp, okay, this t is 0. We can take t equal to 0 here. Here t is 0. Psi is also 0. So psi equal to 0 and t equal to 0 at cusp. Okay, A0. So at the cusp, A0 is there. So that means theta is 0, R is A, theta is 0 here. So the angle T is also 0. T is 0 at the cusp t is 0, psi is 0, t is also 0. Therefore limits will be 0 to here t. Now s equal to, we are finding out the limits from the cusp. Now length of the arc from the cusp, let me write here, length of the arc from the cusp, second point, this is second point, we are finding out length of the arc from the cusp on the x-axis. This is given to us. So on the x-axis, this is cusp is this a0. So we can take here t equal to 0 as psi is also 0. Okay, so this is the point here. So initially from 0 to t, 0 to 2 here, and again ds upon dt into dt. ds upon dt, we have to write here. Limits are now 0 to t only. Okay, that's the point. So that was ds upon dt was this value. That was 3 upon 2a into sine 2t. Okay, sine 2t. Now t was omega here, but that let me write later. But this is 3 by 2 or 0 to t here, 0 to t. Okay, so this is 3 by 2, let me take outside, this is sine t, sine 2t, integrate with sine 2t into dt, sorry, this sine 2t into dt. If I integrate this, it will give us, let me take here. So what it will give us? Okay, so this will give us 3 by 2a. Second point we are calculating, 3 by 2a. Okay, integration is minus cos 2t upon 2. Here 0 to t. It will be 3 by 2a minus cos 2t. 3 by 4 here, let me check. Okay, and plus, it is in terms of cos square t, sin square, no problem. This is minus plus in between, and cos 0 is 1. This is 1.2 here. First is t. Okay, and if I put 0, okay, no problem. So this will give us 3 by 4a. Oh, sorry, 2 I have taken already, so this is 1 only. I'm sorry. But 1.2 I have taken outside, so this is 3 by 4a. This is only 1. So this is 1 minus cos 2t. But this will give us, okay, 1 minus cos 2t is 2 sin square t. This is 3 by 4a into 2 sin square t. 2 sin square. So this is nothing but 2 cancel out. So this is 3 by 2a into sin square t. But t is omega. Sorry, that's psi angle. So let me substitute here. Therefore, s is equal to 3 by 2a into sin square psi. Here psi is minus t undoubtedly. Psi is equal to minus t, no problem. But here it was negative sign initially and minus sign here. But that minus sign I have taken positive. Sorry, that is okay. 1 minus cos 2t comes out. But if I put sign, this is a numerical value, because this is, even if it is negative, sorry, this is a square here, I'm sorry. If I put minus sign, it will be whole square of that, so it will be positive. It will be 3 by 2a into sin square psi, positive. Because psi, if I put t equal to minus psi, t is equal to minus psi if I put. But this is whole square, so whole square will make it positive. So this is 3 by 2a sin square psi, which is the right answer of it. Okay, so this is the second part of this here we have done the two parts of this question. Both the two parts or both of the parts are finally solved. Question number 8 we have now completed. Okay, second part is this 3 by 2a. It says that s equal to 3 by 2a sine square psi, where s being measured from the cusp on the x-axis. On the cusp, x-axis on the cusp on the x-axis, we are having a0. 0 is value of theta or value of t here. Okay, the value of theta at t0, t0, then omega is also 0, sorry, psi is also 0, psi angle. Angle psi, this is psi angle, ps by omega, this is psi angle. So we take psi angle as, sorry, this is omega, I am taking psi angle, this. Psi angle, because t was minus psi, we proved t equal to minus psi. So that if I replace ty minus psi, but it will become positive because it is sine square. So that is the second part of this. So second answer is this, hence proved. So this is proved. Question number 8 finally we have done. Now let me take ninth question. Question number 9 here is of what kind? Let me check. Okay. So question number 9 here says prove that the intrinsic equation of the cycloid. Okay, let me put the question number 9 here. It says cycloid is x equal to a into, is it theta plus sine theta, and y is equal to, okay, a into 1 minus cos theta, where s to prove that, to prove here, to prove s is equal to 4a sin psi. This we have to prove here. Undoubtedly we will prove this. So 4a sin psi. Here, hence or otherwise, find the length of complete cycloid. So the complete cycloid will also be, you will calculate the value of the whole cycloid, complete cycloid. What is the total length of the cycloid, that we will find out. Okay, so you will take that. But before that, let me take this question. So it says, prove that the intrinsic equation of the cycloid, x equal to this and y equal to this. Solution. Okay, now if I just solve it, so differentiating it with respect to theta here, theta is a parametric, this is parametric form. So differentiating first and second with respect to theta, we get dx d theta. Dx d theta here is in the first one, it is 1 plus cos theta. Why? Because theta is differentiated as 1 with respect to theta, and sin theta is differentiated as cos theta. Differential sin theta is cos theta, and d by d theta in the second, this one, this is a into cos theta is differentiated minus sin theta, but minus sin is already there, so it is positive a sin theta. Okay, so therefore now ds d theta whole square, length of the arc we have to find out. So let s is the length of the arc. Okay, where length of the arc, okay, you will take theta equal to 0 to t, because from the vertex of this to any point theta here, theta equal to 0 to theta we will take. Okay, so from the beginning, let me take length of the arc is from 0 to theta. So dx upon d theta is nothing but dx upon d theta whole square plus d by d theta whole square. This we calculate. Now let me solve it. Here it is dx d theta, that means a square into 1 plus cos theta whole square plus a square into sin square theta, because this is d by d theta whole square. If I take a square common, you will get 1 plus cos square theta plus 2 cos theta plus sin square theta. It will give us a square. This is 1 plus 1 y1 because it is sin square theta plus cos square theta plus 2 cos theta. It is nothing but a square within bracket. It is 2 plus 2 cos theta. Because this is 1 here, 1. This is equal to 1. So sin square theta plus cos theta is 1. 1 plus 1 2. 2 plus 2 cos theta. Okay. Therefore, ds d theta, which we have to calculate here. Ds d theta therefore is equal to a square root of this. This is 2 plus 2 cos theta. Now if I write it as, okay, let me take under the square root. If I take 2 common, this is 1 plus cos theta. Okay, so it will give us further a, under the square root, it is 2 into 1 plus cos theta is 2 cos square theta by 2 or 1.2 theta. Simple. Now let me take next point here. Further, this will give us ds d theta we are calculating is equal to a. Now 2 can be taken outside because now it is 4. It will be 2 into a. It is twice a. Now a is already there. 2 will come out from square root and cos square 1.2 theta. So square root is cancelled out. So it is only 1.2 cos theta. This is value of ds d theta. Okay. Now let me find out what is tan psi. What is value of psi angle? Now we know that tan psi equal to d by dx. This is d by d theta upon dx d theta in the denominator. Sorry, d theta. Sorry, dx d theta in the denominator and numerator d by d theta. So it will give us now dx d theta. Sorry, d by d theta is a sin theta divided by this is a into 1 plus cos theta. Okay, so this will give us a cancelled out. A can be sin can be written as 2 sin theta by 2 into cos 1.2 theta angles divided by 1 plus cos theta. That means 2 cos square 1.2 theta. You know that cos 2 theta is equal to cos 2 theta is equal to 2 cos square theta minus 1. So 1 plus cos 2 theta equal to 2 cos square theta and 1 plus cos theta equal to 2 cos square theta by 2 or half angle. Angle will be halved. Now here 2 cancel out. 1 cos cancel out. It is nothing but tan theta by 2 or 1.2 theta. So tan psi equal to tan 1.2 theta. This implies that psi angle is equal to that angle psi equal to, therefore, okay, so then ds d theta we have calculated this value which is to be required. Now let me write here. So therefore psi angle is equal to half theta. In place of half angle, half of theta angle, we'll put psi angle finally. Okay, so now let me take, therefore what is the length? Now we have to find out that hence or otherwise find the total length. We will calculate later, but before that we have to prove that s equal to 4a sin psi. S equal to 4a sin psi. This we have to find out. So let me now put ds d theta. Therefore ds d theta within the limits. Okay, so therefore let me write here. Length of the arc. Length of the arc of the cycloid. Here it is cycloid. Okay, length of the cycloid. Length of the cycloid. Okay, this given above. S is equal to length of the arc. Now limits we have to put 0 to theta. Try to understand from the initial point or from the vertex or from the initial line. Does it say anything? Okay, so we will just generalize the result. Hence or otherwise find the length of the complete cycloid that we calculate prove that the intrinsic equation of the cycloid is this. This intrinsic equation we have to find out. So this is ds d theta into d theta. Now ds d theta is this value. This is twice a. Let me take out of kind of integration. This is 0 to theta. This is cos half theta d theta. Now let me integrate this. Cos half theta is integrated the sine twice a into which is sine half theta positive value upon 1 upon 2, that means 2. So this is integration 0 to theta. Now it is giving us twice 4a. It is only 4a, 2 to the 4. 4a into sine half theta only, because at 0 it is 0. But half theta equal to psi angle, that we have proved. In place of half theta, we can put here psi. It is nothing but 4a sin psi angle. Alright, so this is psi angle here. Got the point? It is 4a sin psi. 4a sin psi. First answer is obtained. This we have to prove. 4a sin psi. This is the length of the arc of the cycloid here, from taken 0 to any angle theta. Okay, any point up to theta. So this is the first part of this. Second part, which says that find a total length of the cycloid. So let me find total length of the cycloid here. Total length of the cycloid will be what? Just from this ds upon d theta, only limits we have to substitute. Only limits here we have to substitute here. So if I find total length of the cycloid, then in this case we have to put the limits here. 0 equal to twice of that we have to do. That we have to do twice of the length. Okay. Or if I find this is 10 psi equal to, okay, what was the point here? 4a. Question was solved. Okay, that was 4a sin psi we have proved. First part is solved. Now complete, for the complete answer, this we have to substitute the limits 0 to pi by 2. Why 0 to pi by 2? That I have to just think about. That it will be 4a sin psi. So because this half length we calculated, so twice of that length if I just put here. So in this case cycloid, okay, from initial point 0 to pi by 2, because at one of the curve if I take, then twice of that, so that will give us the total length.